Hello everyone, welcome to my YouTube channel. Today's point of discussion is Gyrator circuit, which can be used to synthesize inductors from capacitors. So the question is, can we actually synthesize inductors from capacitors? There is only one way to find out. Let's get started. So today's point of discussion is Gyrator circuit, which is used to synthesize inductors. So the main point is, or the main question that everyone will get in their mind is, if we already have inductors, why do we need to even synthesize? What are the benefits of synthesizing the inductors? If we can synthesize the inductors, then why do we have inductors in the first place? So the point is, why do we need to synthesize inductors? Okay. The first reason is inductors are bulky. And the second reason is inductors are costly. So now, if I synthesize the inductors using Gyrator, not only I'll get small size inductors, but also cost effective. So I can save in terms of size as well as cost, and I can get the inductor without actually using the inductor. So now another question is, then why do you have inductors? If you can synthesize the inductors, why do you even sell inductors, or why do you even need inductors? Is there any limitation for Gyrator circuit? Yes, there is a limitation. It is only used in low power applications. So whatever the inductor that we are getting, it is only used for low power applications and not for high power. Say this can be used for an applications where the power rating may vary from few milliwatts to few fraction of watts. But if we need an inductor which carry few amperes of current to tens of amperes of current, then we cannot use this. So these are only for low power applications. And if our applications are high power, then we cannot synthesize because these are only limited for less power. So in that case, you need actually an inductor, actual inductor, not the synthesized one, and you have to use that inductor as it is. But when your application is low power, then in order to save size as well as cost, you can emulate the inductors and use this uh, synthesized inductor in your circuit. So that's the overall background of why do we need a Gyrator circuit. So now that we have understood that why do we need the Gyrator circuit, now we'll get into the details of what is a Gyrator circuit. So Gyrator circuit is a two-port network. So this is a Gyrator circuit, and it's a two-port network, which you all might have studied. So two-port network has two ports, and we have to be very clear with the polarities. The polarities should not be changed. So this is plus minus V1, and this is plus minus V2, and the parameters are entered. So Gyrator is that two-port network with this input-output voltage current relationship. So the relationship is I1 is equals to G times V2, and I2 is equals to minus G times V1. Here G is Gyrator constant. So Gyrator is that two-port network with this current voltage relationship. So now how do we synthesize, or how do I synthesize the inductor? So let us get into it. So now the point of discussion is synthesizing inductor. Okay. So now what happens is, let me connect a capacitor here. Okay. And if this is the polarity of the capacitor, then current through the capacitor will be like this, right? IC. And let me write the IV characteristics of a capacitor. IC is equals to C into dVc by dt. And IC is what? Minus I2 because it is in the other direction. And VC is what? dV2 by dt. Now what we have to do is we have to substitute this I1, I2 in this equation. So let me replace I2 with G minus I2 with G times V1 and C d by dt of V2, which is I1 by G. So now if I change this or if I rewrite this equation in a different way, I will get something like this. V1 is equals to C by G square into di1 by dt, which can also be written as something like this, L into di1 by dt. So V1 and I1 relationship resembles that of an inductor, where the inductor value L is given by C by G square. So now I can play with the gyrator constant and the capacitor value to get the required inductance value. So now, as if this entire circuit is acting like an inductor. So the voltage across that entire circuit V1 and the current entering that entire circuit I1 resembles that of an inductor. So we are getting V1 equals to L di1 by dt, where L is C by G square. So now I can use this circuit and play with the gyrator constant and with the capacitance to get the required inductance value. So this is the overall theory behind the gyrator circuit, how we are getting the inductor or how we are synthesizing the inductor using the gyrator circuit by connecting a capacitor at the other pole. So now we'll see, okay, now we are getting the inductor, but how does the gyrator circuit work? How are we getting this relationship? How are we getting the gyrator constant? And what is the value of gyrator constant? And what is actually the gyrator circuit? So now we'll go into the details of this gyrator circuit. So this is the gyrator circuit which we are going to discuss now. Okay, so please pay attention and see how we are getting the relationship. So now we are going into the details of the gyrator circuit. So this entire box is the gyrator circuit. Okay. As you know, if the op-amps are connected in the negative feedback fashion, their minus terminal, which is the inverting terminal, and the non-inverting terminal are virtually shorted. So let me show which terminals are shorted. So this terminals are shorted, and this entire terminal is at the same potential. Similarly, these two terminals are shorted, and this entire terminal is at the same potential. Okay. So now I have marked the terminals which are at the same potential. And we've seen that voltage across the capacitor is V2 and other terminal is V1. Okay. So, sorry. This voltage is plus minus V2 and the current is I2. Similarly, this voltage is plus minus V1 and current is I1. So the left side of this voltage is acting like an inductor. Now the question is, why do I need resistor which is connected in series with the inductor? So there is one important thing that you need to understand here. Say I have a voltage V and I have an inductor connected directly to a voltage source V. So now what happens is, we know that V is equals to L di by dt. If voltage is constant, then current will keep on increasing and it will reach infinity or it will damage any of the components. So who limits the current? So we connect a resistor R in series. Now what happens is I max will be V by R. So for that reason, for the protection purpose and to limit the current, we connect a resistor in series, and that's why this resistor is connected in series. If the input is AC, still if we connect resistor, it will be on safe side, because even if there is slight DC value in the circuit, the inductor current will keep on rising, and in order to put a limit or to protect the devices, we need to connect some series resistance which will limit the maximum current that is flowing in the circuit. Okay. Now if you see, we also know that the current that is entering the op-amp will be 0. So this current is 0. This current is also 0. Similarly, this current is 0. This current is also 0. Okay. Now let us start from the left side of the circuit. So this is V2. So this terminal is also V2, which means this terminal is also V2. So the current that is flowing in this resistor is V2 by R. The same current will flow in this resistor because there is no other path. The current entering the op-amp is 0. So this is also V2 by R. So this terminal is at V2 and current is V2 by R flowing through the resistor. So what will be the polarity or the potential at this terminal? 2V2. If this is 2V2, Then this is also 2v2 because these two are again shorted. So let me use another color and show you that these two terminal, this entire thing is also at the same potential. Okay. Now you see that this is at V2 and this is at 2v2. So the current will be V2 by R. So in this terminal, the current is I2 because there is no other path for the I2 to flow because the current entering the op-amp is 0. So now we can see the current flowing through the R resistor is I2 plus V2 by R. So this is the current that is flowing through this resistor. Okay, that gives us the current value in that resistor. Now let us come back here. Because this is V1, this is V1. So this entire voltage is V1. So this is also V1. So now the current that is flowing in this resistor R is what? 2V2 minus V1 by R. Provided I am considering this is the direction of the current. As this current cannot enter the op-amp, the entire current will flow in this resistor, which is 2V2 minus V1 by R. Now V1 is at a higher potential and this is at a lower potential. And what will be the value of this potential? I will get something like this: V1 minus 2V2 minus V1 by R times the resistor value R. So this potential is 2V1 minus 2V2, right? So 2V1 minus V2 is the potential of this terminal, And this terminal is at what potential? This terminal is at a potential of V1. So now if I calculate the current in this, I will get V1 minus 2V2 by R. As this current cannot enter the op-amp, the entire current flows through this path and the current value is V1 minus 2V2 by R. And this current is I1 and the current that is coming from the top is I2 plus 2V2 by R. Now if I apply KCL at this terminal, the summation of all these currents will be 0, right? So what is the, if we apply KCL, what is coming at that terminal? Something is I2 plus 2V2 by R. So we have I2 plus 2V2 by R plus current from the bottom is V1 minus 2V2 by R. V1 minus 2V2 by R. Sorry, yeah. I2 plus V2 by R. So I have made a mistake. This is I1 plus V2 by R. Sorry, I2 plus V2 by R. So this is also I2 plus V2 by R. Sorry for the mistake. And then the third current is I1. So plus I1 is equals to 0. So now if you simplify, I will get I2 plus I1 plus V1 by R minus V2 by R is equal to 0. Okay. So this gives me my first equation, equation 1. Now if you see, the current flowing through this resistor is I2 plus V2 by R, but the left terminal of this is at the potential V2 and the right terminal is at the potential V1. So this current is also equal to V2 minus V1 by R. So we will get another equation I2 plus V2 by R. I2 plus V2 by R is equal to V2 minus V1 by R. So from here, you will get one expression which is I2 is equals to minus V1 by R. So this gives me one equation. Now if we substitute this here, I2 is minus V1 by R, then we'll get minus V1 by R plus I1 plus V1 by R minus V2 by R is equals to 0. So from this I will get I1 is equal to V2 by R. So now I'll write it something in this way. So I'll write I1 is equals to G into V2 and I2 is equals to minus G into V1, where G is defined as 1 by R. So this is what we are getting from the circuit by solving the circuit. So if you see, I1 is G times V2 and I2 is minus G times V1. So which is what we have learned at the beginning of this discussion, and which is what we are also getting here, right? So this is what we got by solving the circuit. Now, if I write it in a different way, I can write it something like this: I1, I2. In terms of V1, V2, if I write it in terms of matrix multiplication form, then I will get I1 is 0 into 3 times, and I2 is minus G into V1. So I'll get something like this. So this is V1, V2. Here, G is equal to 1 by R, which is the Gyrator function. So here we have seen how that gyrator circuit is acting like this. How we are getting this current and voltage relationship from the circuit. So now this entire circuit, if you see this entire circuit, so let me do this. So now what happens is this entire circuit. So this entire circuit is is equivalent to an inductor L, where L is equals to C by G square, and G is 1 by R. So we will get L is equal to R square into C. So now this entire equation, the entire expression, or the sorry, entire circuit can be simplified as V in RL and L. So the entire circuit that we have initially, we have simplified it, and we'll get something like this. We have RL, we have one source, put VAC, put VDC, and I'm calling this as V input, and this is resistor RL. This is L, which is R square into C. Now I can choose R and C in such a way that I'll get my required inductance. This is the synthesized inductor using Gyrator. So now we got a simplified circuit with the inductor, but in the actual circuit, we have not even used any inductor. So in today's discussion, we have actually learned what is a gyrator circuit and why do we need to use gyrator circuit to synthesize inductors, and how can we actually synthesize inductors, and what is a gyrator circuit, and how can we get the input output voltage and current relationship of a gyrator circuit. So with that, we'll end this discussion here, and I hope you have got some knowledge and understood what a gyrator circuit is and how can we synthesize inductors. We'll meet again with some other interesting circuit and some other interesting concept. Catch you guys later. Peace.